All right, welcome back. And so now we're going to talk about the intermediate value theorem, okay, and how to apply it, okay? So in many instances, for example, in this case here, there are lots of polynomials where even with our techniques or even with calculus, it is very difficult to find where the zeros are located, okay? Just for example, these are the zeros for this quartic polynomial, okay? So even though we won't, so in cases where we can't determine exactly where the location of zeros might be, even if we use numerical approximation techniques and things like that, we often want to know the existence, right, of zeros, okay? Do zeros exist in a particular interval, for example, okay? So that's where the intermediate value theorem comes in. The intermediate value theorem is a theorem that we use to determine the existence of a zero on a particular interval, okay? So in this case, the intermediate value theorem says let f be a polynomial function. Okay? If A is less than B, oh, I'm sorry, not if, for. For A less than B, so we're given two real numbers, and we're saying A is less than B, if f of A and f of B have opposite signs. Then f has a real zero, or excuse me, has at least, hold on a second, at least one zero on the interval and it's the closed interval from A to B, because it could be one of the endpoints. Okay? Now, before I do an example, got to make sure that you understand the theorem and the extent of how far it will go. Okay? So this is only about existence. It's not going to tell you where it's located. Okay? But it's one about existence. So in other words, again, what it says here is let f be a polynomial function. So if we're given a polynomial function and we're given two values of a, right, on the x-axis where a is less than b. So we're given some interval and these are the endpoints of the interval. If f of a and f of b have opposite signs, which means we're testing the endpoints of the interval. And we evaluate the function at both endpoints, and we turn out that both of those values have opposite signs. Then what that means is that somewhere in that interval, in that closed interval from A to B, there has to be at least one place where it crosses the x-axis, right? Because because remember, polynomial functions are what? They're continuous and smooth. So continuity says that, hey, if it goes from positive to negative, it has to cross the x-axis somewhere in between there. Has to. That's what the intermediate value theorem says. Now, the thing is it could be one, it could cross once, or it could cross multiple times. Okay? We don't know. Now, what if you choose an A and B in an interval, and it turns out that f of A and f of B have the same sign? Does that mean that there are no x-intercepts in that interval? No. Okay? All that means is the intermediate value theorem would be inconclusive, right? There might be, there may not be. Okay? So again, be careful of how far you take the intermediate value theorem. Okay? All it says is if this, then that. Okay? That's all it says. So if this is true, then this must be true. Okay? Otherwise, it's inconsistent. All right. Now we'll come back and do some examples.